Today we are going to start Edexcel IAL Chemistry Paper 3 Part 2. We have already discussed question number 1 and 2 of this paper. Today we are going to discuss question number 3. This is basically May 2019 Paper 2. Question number 3. A group of students carried on an experiment thermochemistry experiment to determine the relative atomic mass of metal M. Procedure: transfer 50 centimeter cube of 1.25 moles per decimeter cube of solution of copper sulfate. Please, when you read the question, always mark the values. So they have given you the volume of copper sulfate, but this is in centimeter cube, so you need to convert this into decimeter later on in the question. And they have also given you the concentration of copper sulfate. So you have these two values. Then weigh out as accurately as possible unknown mass of the finely powdered metal M. So you don't know what is metal M, and you need to know about this. Measure the temperature of the copper sulfate solution. Quickly add all the powdered metal, stir the mixture continuously, and note the highest temperature reached. Each student carried out the experiment using a different mass of a metal. Give a reason other than preventing heat loss for placing the polystyrene cup in a glass beaker. Now you know that polystyrene cup it's quite unstable. So in order to increase the stability of polystyrene cup, glass beaker is used. Okay. Name the piece of apparatus suitable for measuring 50 centimeter cube of copper sulfate. The pipette. This is the best apparatus for this. Powdered metal reacts much faster than fillings. We know this because it increases the rate of reaction. So suggest why this is important in this reaction. So because this reaction is related to the energy changes. So basically the use of powdered metal makes that the heat loss is similar for all experiment run. Now the next part, the student results were calculated on table. Plot a labeled graph of mass of metal on the horizontal axis. Now you need to plot a graph where you need to keep the mass on the horizontal axis and you need to keep the temperature change here on the vertical axis, y-axis. So you need to plot this graph, and the graph will look like this. Okay. So this will be your graph. Now, determine the mass of metal M that reacts exactly with 50 centimeter cube of 1.35 moles per decimeter cube copper sulfate by drawing appropriate best fit lines, straight lines. You must show you're working on the graph. Through graph, you can find the mass that reacts with 50 centimeter cube of 1.35 moles per decimeter cube of copper sulfate. And I have also calculated from the graph, and from my graph it comes 4.3. But I think 4.1 to 4.5 within this range, the graph is fine, I think. Now, the next part of this question, the equation for the reaction of M with the copper sulfate is metal plus copper sulfate, metal sulfate plus copper. Use the equation and your answer to B2 to calculate the relative atomic mass of M. Now, we have the mass of M, which we have calculated from the graph, that's 4.3 grams. Now we need to calculate the relative atomic mass of M. And for this we need the number of moles. And we don't have that. So we first calculate the number of moles of copper sulfate. And you know, copper sulfate and the metal reacts in the ratio 1:1. So 1 mole of copper sulfate reacts with 1 mole of metal. So the moles of copper sulfate will be equal to the mole of metals. So how can we calculate the moles of copper sulfate? We have the concentration of copper sulfate and we have the volume. So we can easily calculate the number of moles by multiplying the concentration and volume. So first we will calculate the moles of copper sulfate. So the concentration of copper sulfate, which is given in the question, and that is, if you look at the question, it is given here and it's 1.35 and the volume is 50 centimeter cube. So we need to change the volume into decimeter cube. So we will divide the volume with 1000. So the number of moles of copper sulfate is 0.0675 moles, and the mass of moles of metal and the moles of copper sulfate are equal. So the metal also have the same moles. Now we need to calculate the relative atomic mass of metal. Now we have the number of moles of metals and we have the mass of metal as well. So through moles and mass, we can calculate the relative atomic mass of this metal, and that is equal to 64. Basically, the correct value is 63.7, and if you will round off, it comes 64. So this is all for this question. One mass of M in the experiment give an anomalous data point suggests a reason for this, other than the measurement error for this anomaly. Okay, yeah, because we can't give the measurement error, so the other reason can be that the temperature of the solution is not uniform. So because of this, an error come is not uniform. And what's the reason for this? How it's not uniform? Because the mixture is not stirred properly. Is not stirred properly. So this can be a reason. So let's start question number 4. Solid sodium hydroxide absorbs water from the air. The purity of the sample of sodium hydroxide may be determined by titration. Weigh a sample of sodium hydroxide in a beaker. Dissolve the sodium hydroxide in distilled water and transfer the solution in washings to 250 centimeter cube of volumetric flask. Make the solution up to the mark with distilled water and mix thoroughly. So as I told you previously as well, that always mark the values when you read the question. So the volume of sodium hydroxide given here is 250 centimeter cube. Now pipette 25 centimeter cube of sodium hydroxide solution. So from 250, 25 centimeter cube of sodium hydroxide solution is taken into the conical flask and add a few drops of methyl orange, which is the indicator for acid alkali titration. Titrate the sodium hydroxide solution with hydrochloric acid of known concentration. Here HCl is used and its concentration is known. Repeat the titration until concordant results are obtained. Mass of solid sodium hydroxide 0.95 gram. Concentration of hydrochloric acid 0.095 moles per decimeter cube. Please mark all these values as well. These will come in use later on. Now, state what is meant by the term concordant results. The results that are within 0.2 centimeter cube of each other are concordant results. So whenever you need to calculate the mean titer, always take concordant result, whether it's mentioned or not, but it's important to take concordant result. Otherwise, your whole calculation will become wrong. So now if we are calculating the mean titer here, first we look for the concordant results, the results which are within 0.2 centimeter cube of each other. So you can see here only two results are concordant. So we will take these values 4.10 and 24.3 and we need to take the average. So the value is 24.2 centimeter cube. This is the mean titer. State the color change at the end point of the titration. Okay, because in the conical flask you are having the alkali and methyl orange is yellow in alkali, and when you will add acid from the burette, the solution will turns to orange due to the presence of acid. Okay. Now D part, the equation for the reaction is sodium hydroxide plus hydrochloric acid, sodium chloride plus water. Calculate the purity of the sodium hydroxide as percentage mass. Now you can see here that 1 mole of sodium hydroxide react with 1 mole of hydrochloric acid. The ratio is 1:1. So you need to calculate the percentage purity of sodium hydroxide. Okay. And how can you calculate that? For that you need to have the mass of sodium hydroxide. Okay. So how we can calculate the mass? We can calculate that from molar mass and the number of moles, but we don't have the number of moles of sodium hydroxide. So for that we need to calculate the moles. We have hydrochloric acid and we know the volume as well as the concentration of hydrochloric acid. So by using the volume and concentration we can find the number of moles by using the formula. Concentration is equal to number of moles over volume, and once we will find the moles of hydrochloric acid, we can also find the moles of sodium hydroxide because they both are equal. So let's find the number of moles of hydrochloric acid. Now calculate the number of moles of hydrochloric acid, and for that you need concentration and volume. The concentration is 0.095 moles per decimeter cube and the volume is 24.2 centimeter cube. So we need to convert the volume into decimeter cube. So we will divide that by 1000. Now the concentration comes 0.002299. The moles comes 0.002299 moles. Okay, so this is the answer. Now these moles are of hydrochloric acid. You know the ratio of hydrochloric acid and sodium hydroxide is 1:1. So the moles of sodium hydroxide will also be 0.00299. But there's a twist because we have calculated the moles of hydrochloric acid and the sodium hydroxide, but here the sodium hydroxide which we have used was the volume which was taken was 25 centimeter cube and the actual volume was 250. Okay, so the volume needs to be 250 instead of 25. So for that, taking the moles in 250 centimeter cube of the volume, we need to multiply this with 10 because we have taken 25 and now we are taking in 250. So we will multiply with 10. 25 into 250, the difference is multiplication by 10. So the value will come 0.02299 moles. Now you have the moles of sodium hydroxide. Okay, and from the moles now you can find the mass because for calculating the percentage purity you need mass. So the mass of sodium hydroxide, how can you find? Number of moles is equal to mass over mR. So how can you calculate the mass? by multiplying number of moles with mR. So the mass is 0.9196 gram. Okay, this is the actual mass of sodium hydroxide. Now, how you can find the purity of sodium hydroxide? Now, if you will go back to the question, you can find out the mass of solid sodium hydroxide. This mass of solid sodium hydroxide, the given here is 0.95. Okay? 0.95, and the mass which we have calculated is 0.9196. So 0.916 divided by 0.95, and we will multiply the value with 100 because it's percentage purity, so it comes 96.8%. Okay, so in this way you can find out the percentage purity. So this is all for Edexcel IAL Chemistry Paper 3. Please watch the videos, subscribe to the channel, and let me know which other year paper you want to solve and discuss with